They are only tiny molecules, but they have the potential to help medical research take the next significant step in the future. Jörg Rademann and his team want to develop new molecules that have the ability to manipulate proteins, which is a characteristic that is important for treating diseases.
We
are developing new molecules in the research group of medical chemistry, which shall specifically bind to the protein surface. The goal is that such binding will allow us to activate or disable the function of the protein. This means that those molecules are important tools for us to better understand the function of proteins in living systems, thereby creating the basis for future development of new medication. Jörg Rademann is especially interested in new methods to find such active molecules. For this purpose, he examines reactions of molecule compounds, so-called fragments, on the protein surface. The goal is to build a particularly active and specific molecule from several fragments using such reactions. To achieve this, Rademann has developed a process called dynamic ligation screening. The process involves a protein binder being made reactive and being able to chemically react with a second fragment. A trick now enables selection of the fragments that bind to the protein especially well. The protein surface serves as the model for building new active molecules. To this end, the research group uses chemical libraries, collections of molecules, that are produced on a synthesis robot. These libraries are stored, well chilled, in so-called microtiter plates. They are pipetted with the protein to be examined in a fully automated process. The researchers can then measure how active the protein is with the help of a color reaction in a so-called plate photometer. Rademann and his team built new molecules from the most active fragments. This is how they've been able to develop a molecule that binds to the surface of a specific protein of the SARS virus. The molecule disables the virus protein and thereby prevents the SARS viruses from spreading in the infected cells. The findings by the Department of Medical Chemistry can also contribute to developing better diagnostic methods, for example for cancer. Special enzymes are overactive in cancer patients. By improving the molecules that bind to these enzymes, cancer cells can be made visible at a very early stage. This is of special significance for pancreatic cancer because it is very difficult to distinguish tumours from infections in this case.
We
want to develop our methods in a way that we will be able to develop tailored molecules for various proteins that bind to their surface. These molecules will then enable us to better examine the functions of various proteins in the case of illness and thereby contribute to healing these diseases.